Good afternoon. My name is Tajuddin Abdulaziz, and I'll be taking you on information technology. And for the topic today is going to focus on computing components, central processing unit, CPU. CPU is a familiar word that almost everybody that has gone through secondary school should be familiar with. So for this topic and for the course curriculum, we'll be breaking down what it entails, what CPU entails, and how the internal working actually takes place. What are the components that it consists of? What are the capabilities, the inputs, the outputs, the functioning system, and the likes? So all these are what we'll be considering. For a CPU, we're looking at what you're expected to know at the end of this course. So at the end of this particular topic, you're expected to be able to explain what a central processing unit is and components and components. And when we say components, we are referring to the smaller part of a something. Smaller part of a something that actually forms the bigger part are the what? Are the components. So in most cases, when we refer to components, we are referring to something that can be either dismantled or that can be coupled together. So it's going to divide bits and how series of bits represent data in our system. You should be able to differentiate among the common types of memory that we have. And lastly, you should be able to understand how to care for your computers and your mobile devices. So these are going to be our learning outcome for this program. Now, central processing units, CPU. We have three parts for the naming. We have the central parts. Now, when we say central parts, in most cases, we are referring to a meeting point for several operations. Okay. So, and when we refer to processes, processing refers to the way things are being done, and unit of a thing refers to just a singular part of a bigger thing. Okay, so central processing unit is a central point where things are being done. So it is also known as the processor. And the word processor is actually a good nomenclature for what central processing unit does, because it processes so many things. So the first thing we'll be looking at is what it does. And what does the processor do? It interprets and carries out basic instructions. So when we say instructions, what do we mean? When we say instructions, so for a computer, instructions are just step-by-step process that are being sent to the computer. So there are step-by-step processes that are being sent to the computer, or a step-by-step tasks that are being given to a computer. And all these are referred to as instructions. And once an instruction comes from the user end, so that means there must be something interacting with the processor. And in most cases, that should be that should be human. So a user that uses the system will send in a set of instructions. And this set of instructions need to be processed, need to be interpreted for the machine to understand. So the major function of our processor is to just interpret this set of instructions, and it controls computer operations, because computer is actually meant to either break down a process for us or build up a process for us. So once a or set of instructions are being sent, it moves forward to interpreting it and either breaking it down. And as a result of that, the operations in the computer will be changed towards achieving that goal. And these operations are being controlled by the processor. So when we say processor, what do you vision? What do you think of? What comes to our mind? That okay, this powerful machine, this powerful aspect of your computer, how does it actually look like? What are the core components that we have in it? Now, the diagram that we have here, diagram 2.1, the CPU on top of the personal computer motherboard. And looking at that image, we have a motherboard that is housing where our CPU is. And this CPU is like the brain of your computer. It's like the what?
The brain of computer.
So it's like the brain of our computer, because it's just like human brain that is responsible for processing all human activities. So while the brain of humans is made up of, is made up of neurons, cells, a bit of electrical circuits too. For computer, it is actually collections of complex electrical circuits. Collections of complex electrical circuits of transistors placed over an integrated circuit control unit and arithmetic logic units. So like I said, just like human brain, a human brain has a lot of collections of neurons that are interconnected together, that is responsible for sending electrical signals from one part of the brain to another part of the brain when there's a message, or when it receives a message or is trying to send a message. So this part of the brain, or this simulation, is what we have in our computer, having collections of electrical circuits, many electrical circuits that has the capacity to actually decode messages and function together as a system. So control units and arithmetic logic units works hand in hand to make sure that all instructions have been interpreted appropriately. And this leads to what are the functions of the central processing units. Now, it executes software instructions to machine readable form instructions. So when we say software instructions being sent by a human will be received by the machine. Now, your computer does not understand the set of instructions you are sending. You are saying copy or paste. It does not understand that, because those language is not a machine readable language. So those copy or paste have to be, it has to be broken down to the smallest units in one and zeros that are understood by the computer. Excuse me. So these are now broken down and are being sent as a set of instructions in a language that the machine can actually understand. So the important function of CPU is to what? Is to execute those instructions. to what your machines can actually read. So components of your CPU and how these are actually being carried out. The images here shows a RAM. A RAM is referred to as the random access memory of your computer. And this part of the computer is responsible for storing information that has been executed by your computer, central processing unit. So once you've stored the information, you can actually retrieve them. So in most cases, what you do with the RAM is you fetch some set of instructions from the RAM. And information that lives in your RAM are short-lived. They are what? They are short-lived. Just like in our brain, we have long-term memory and short-term memory. Long-term memory can be there for a very long time, while short-term memory are there for when it is actually being needed. As long as it's actually being needed, that's where we have our short-term memory. And that is what your RAM is. Your RAM is just short-term memory of your computer. So you can fetch the data from it. And this data will be sent to your control units. At the control units of the CPU, you have the instruction being decoded. So it decodes the information, it breaks it down, specify it, so that the computer can understand it. Then send the information to where the information will be processed further, or let's say where the information will be executed. Now, this information has to be executed. You are not just sending some set of instructions for sending sake. You want to perform something. So the set of information will be executed there. And these executions take place in the arithmetic logic units of your CPU. So that means for your CPU, you have subunits, the control units and the arithmetic logic units. Do you get that? How many units do you have in our control unit, in our CPU?
Two
Hello?
units.
We have 2 units. The first unit is what?
Control unit and arithmetic logic unit.
The control unit, and second is what? Arithmetic logic unit. So these 2 units works hand in hand together. Just like I said, this thing actually emulates more of our brain. In our brain, we have different aspects of the brain. The part that controls all the movement of the body, and the part that controls our involuntary part of our body, like the way our heart beats, the way our lungs, works or breathes and the likes. How this thing works. Okay, so these 2 parts work together, and it produces a result. It produces a what? A result, and these results are being sent to the RAM. Are being sent to the RAM. So let me take for example. So this actually happens in a circle. We call it what? Machine circle, whereby you fetch, you decode, you execute, and you store. Fetch, you decode, you execute, and you store. Let me take for example that I want to create an image for my computer using a software called CorelDRAW. And with this software, I started creating an image. And the moment I created this image, as I'm doing this, my computer, my CPU is processing each of those commands that I'm sending. And each command are being processed, are being looked into, broken down to interpret. So as I'm sending those commands in my own language, in the normal human language, which the computer does not understand, so the computer should now break it down, okay, and understand what it needs to perform. And once it's able to perform that, it's send the result out to me. And that's what I'm seeing. And by the end of the day, the result will be kept in my random access memory. That's my what? My RAM. And the cycle continues. The machine cycle continues for every processes that we have. Now let's take a further look into each of these processes. Like I said, the units, your central processing unit is actually a system that contains a sub-unit like other units. And the first part is your what? Is the control unit. So control unit does what? Majorly, it directs other units. or sections to execute instructions. So that means there are some departments within that control units. You have other departments there that respond to the control unit. So the control unit is the head department that directs those departments. So they wait for instructions from the control units before they can execute their own instructions. So what other things does the control unit does? The control unit controls and coordinates all computer activities. Now, with your computer, you know you can do several things, right? You can start using your keyboard to input things. You can use your keyboard to type text, to play game, and do so many other things. And these activities are actually being controlled by your control unit. You can use your system to watch movie or to make movie. If you are watching movie, in that case, what you are doing is that you are only flashing an image message that has been decoded from your control unit to the screen. But if you are making a movie, in that case, you are actually writing some code, setting some information or data that are being collected, processed, and being executed to give a set of results that will transform into images, sounds, and the likes. And this becomes what as a movie. So aside this tool, it also directs data movement between your memory and your arithmetic logic units. So that means for every time you are working on a computer, there are movement of data from one part to another. Depending on where the data will be needed, the data will be moving from the memory and to the arithmetic logic units, or it's been moving between your memory and your I/O devices. And what are your I/O devices? Your I/O devices refers to input and output devices. And input and output devices for your computer, for example, for every personal computer, you have your keyboard and your mouse. Your keyboard and your mouse are referred to as your input devices because from there you can input some set of instructions to the computer. Now, what about your output devices? So what do you think your output devices will be? Anybody? What do you think your output device will be? Any idea? Do you have any idea what our output device will be? Do you have any idea of what our output device will be? So your output device is actually your screen. It's actually your what?
Screen.
The output device is actually the screen that. So just like the way you are seeing my presentation now, via your what? Your screen. Either it is your mobile screen or your laptop screen. You are seeing an output of my presentation via the screen. So that is just an output devices. And we have several other output devices that we're looking at after in some particular slide that we have prepared for us. So we've looked at and we discussed what the control unit is. Now, can we discuss what our arithmetic logic unit is? Like I said, the arithmetic logic unit is just the units or the components of your CPU. And together with the control unit makes up the central processing units. And the first thing we want to look at is what are the functions of these things, of this unit. And what it does majorly is it performs basic arithmetic operations. We have operations like addition, multiplication, subtraction, division, modulus, exponential, and so on and so forth. So these arithmetic operations are being performed within the arithmetic unit. So after the controls happens with your control unit, any arithmetic that needs to be processed are being sent to the arithmetic logic unit. And in that environment, your calculations comes up. So what does it do aside the performing of basic arithmetic? That or no? It also complex operations such as the equal to sign. So operations like comparative operations. We are comparing two things together, like is Is A equal to B? Is A less than B? Is A greater than B? Is A equal to or less than B? Is A greater than or equal to B? All these operations are performed within your arithmetic logic unit. Now, let's look at another thing that it does. It performs logical operations. Performs what? Logical operations. And when we want to give some of those logical operations, we refer to as what? And, or, and not. These three operators are actually referred to as what? Logical operators. And that's why it is being said that it performs logical operations. So, and the use of and, or, and not are actually some essential part of what your ALU unit does. An example of that is I can say that if your system is on and it is charging, the light should be on. So that is a logical operator because it holds two conditions. Your system is on and you're charging it. It holds two conditions. So, and those two conditions must be true before the operation is being carried out. But for your all operators, it happens such that I can say that if your computer is on or if you are charging your computer, the light should be off. Either of the two, the light will be off. And the third part, which is not, I can just say that when you are not on a system, your system should hibernate. So that means, like I said, when you're not using your system for 10 minutes, it should hibernate. So this type of logic operator is carried out within your arithmetic logical units. Personal computers and mobile devices processors. Because you know that for every computer, what it does basically is to process our work. And for human being, we love to get our work done faster. Nobody wants a slow computer. And with development, research, and progression, we have CPUs that are very, very fast and process billions of information at milliseconds. And these have been made possible by some leading manufacturers of either your PC processors or your mobile processors. Now, we'll be familiarizing ourselves with this word manufacturers. The first is the Intel. The Intel is actually a processor manufacturer, and most of your HP comes with an Intel processor. Most of your HP computer comes with Intel processor, and we have different processor power depending on the type of system you got, and of course depending on your budget. That goes in along to determine the type of Intel that you have. We also have a AMD processor. Processor is also being produced by AMD manufacturer. We have the VIA processor. So this image shows your AMD processor, and this shows your Intel processor. So these processors are actually a very strong processor for you find in any of your computer at all. And you have to look at the mobile part of it. Because the world is going mobile every time. You have more mobile device usage overgoing your laptop usage. So, and some of the leading manufacturers in this company are the Qualcomm Snapdragon, the Huawei J, and Samsung Cosmos. They have the NVIDIA program. So all these people are involved in serious mobile device processors. So NVIDIA is coming up recently and is going great in graphics card production, allowing heavy users of graphics card to enjoy different processes like builders of all the architect softwares like Events and AutoCAD, other powerful software like that in game development. So how do you select the right processor? So now the question is, as an information technology student, if you want to go for a laptop or want to go for a personal computer, what are the guiding information that you need? So the first thing is what guides you is dependent of the needs, what you need for. Then you want to determine your current processor before you want to upgrade to another one. Then your research processor problem. How do you find out what best processor produces what you need? So let me give you a scenario. Let's say, for example, I'm a graphic designer and I work heavily with softwares like Adobe, Photoshop, Adobe, CorelDRAW, editing, and the likes. And I'm working on some other sophisticated softwares that need me to design at high level. You know, at high level, I might want to consider processors like AMD for my personal computer because I'm acquainted with the fact that AMD goes extra mile in designing graphic cards for graphic designers. So for a software engineer, I'm working more on software development using languages that we are familiar with, like Python, JavaScript. And I'm comfortable with my Intel processor, going for a high-speed Intel processor and okay for me. And with that, I'm able to develop that having issues like system handling, delaying, and the like, because the processor is equivalent to the job I'm doing with it. So we have examples of the mobile processors that we have here that are going to use different mobile phones. So the processor chips generate bits that could cause the chip malfunction or fail, require additional cooling. What we are saying is that because of different powerful processes that is carried out, that's being carried out, it actually automates each generation. So out of which will be generated via your CPU, and it can actually affect and this it can affect the way you work with your system. So I would now say that the first thing you want to do is to make sure that the system is going to so what do you want to do? You want to consider a very cooling system. So, hello, are you there? Can you hear me?
Yes, sir.
Okay, so give me like few like 2 minutes.
Okay, sir.
Hello.
Hi.
Should I welcome myself back?
Yes, sir.
Can you see my screen?
Yes, I'm seeing it.
What's recording? I thought I paused this recording. What's happening?